So today's lab is on LeChatlier's principle. And if you recall, LeChatlier's principle states that whenever any equilibrium system that is subjected to a stress, it is going to counteract that stress. So we have three parts to this lab. In part A, we're going to be evaluating a cobalt chloride solution. The cobalt chloride is going to be dissolved in alcohol. And it's going to start as a vibrant purple violet color, and we're going to subject it to water and see what happens to that system. In the next tube, calcium chloride, but specifically the chloride is what's important here. And then in tube E, acetone, and then tube F, silver nitrate. In part B, we're going to be working with a copper sulfate system. Copper sulfate is a pale clear blue. And in the first tube, we're going to be adding ammonia. In the third tube, we're going to be adding ammonia and then subsequently hydrochloric acid. So we're going to record the observations stepwise. So first after what happens when we add ammonia, and then what happens when we add the HCl. In the next tube, we add ammonia, and then we're going to add sodium hydroxide to that. And then in the final tube, we add the ammonia, and then we're going to change the temperature and put it into an ice bath and see what happens. In part C, we're looking at a potassium chromate solution. So we are going to subject it to sulfuric acid, record what happens, and then sulfuric acid, and then sodium hydroxide. So we're going to go through all of these stepwise and record the results after each addition. All right, so here we are at the start of part A. Notice that we have this cobalt chloride solution. It's a violet, almost indigo colored solution. And I've poured into about 2 milliliters into each of these test tubes. So tube 1 is going to be our control. All right, so it just looks just like the solution in the bottle. So we're going to start reacting tube 2. And to tube 2, we're going to add water. And as I mentioned earlier, that the cobalt chloride right now is dissolved in ethanol. It's not dissolved in water. So let's see if there's a change by adding water to it. So we'll do one drop at a time. You can almost see there's a little bit of a color gradient there. Almost got lighter at the bottom. So if we compare it, oops, actually did that to the wrong tube. So we'll use this as our new tube 1. So by adding water, the solution is no longer violet. Let's go ahead and add another drop. Another drop. So basically, and do our fourth drop. Adding water results in a pink solution. So the water is now bonded to the cobalt ions, and the color that we see then is pink in an aqueous solution, whereas when dissolved in alcohol, it's violet. Okay, so to tube 3, we are going to add hydrochloric acid. So we've got some hydrochloric acid right here. So tube 3. Notice the change in tone. We went from a violet to a blue. Let's add just another drop. So by adding hydrochloric acid, the result is a translucent blue color as opposed to violet. To tube 4, we're going to add calcium chloride pellets. And calcium chloride pellets are hard, they're pellet-like, and to make the reaction happen faster, I had smashed some between two watch glasses, and that's going to make them dissolve faster and react faster. So I'm just going to scrape some of this powder into the 4th tube. And we're seeing us change from our violet to our light blue. It's very similar to the hydrochloric acid. To tube E, we're going to add acetone. So we get this, initially we get this blue color. Add a little bit more. Yep, definitely get a blue, nice translucent blue again. And to our last tube, tube F, we're gonna add some silver nitrate. So we get a pink color to return, and we get some cloudiness, some precipitate. Which, if you know your solubility rules, that should make sense. Here are the 6 tubes again from left to right. All right, so part B, this is the copper sulfate system. We're using 0.1 molar copper sulfate, which is this nice clear blue. And the first thing I'm going to do is to add ammonia to each of these test tubes, tubes B through E. Of course, tube A is going to be the control. So I'm just going to go ahead and do that now. Oops. So initially we see we get some cloudiness. And to each of these tubes that I added the ammonia to, we're getting the same cloudiness initially. But I'm going to continue to add more ammonia. And we'll see what happens if we add a few more drops to each. Now, if we keep adding ammonia, we get this very vibrant, deep blue. So let's go ahead and repeat that for the rest of the tubes. All right, so we've added ammonia to all of these test tubes, and we see the same deep blue translucent color. This is due to the formation of the tetraamine copper ion. It's a complex ion. And we're going to see what happens now with the addition of hydrochloric acid. Now, ammonia is a base. Hydrochloric acid is obviously an acid. So let's take tube C and add acid dropwise. Let's see what happens. Oh, we have we're no longer as deep blue as we were. Oh, we saw precipitate, which means we went back to the cloudy, and then now it's the translucent blue again. So we basically brought it back to its original state. It went through two stages. Right? It went from the deep blue to the cloudy, opaque, light blue to the clear light blue with the addition of HCl. So that would be two separate reactions stepwise. Now we're going to take our solution and we're going to add sodium hydroxide to it. Let's see what happens. And as you can see, we get cloudiness forming. Right? Remember, cloudiness is a sign of precipitation. So I wonder if we can get this back to be translucent like the HCl did. Let's see. Nope. I added a fair amount, and this solution is going to stay as an opaque, cloudy, light blue solution. For this last tube of this set, we're going to take our tetraamine copper tube and we're just going to let it chill. And we'll come back to see what happens to this guy after a few minutes. All right, so let's see what happens after our system has been sitting on ice for a while. We're going to use the colorimeter. So the first thing we need to do is calibrate the colorimeter. So I've prepared a blank of deionized water. Set the wavelength to 635 because it's a blue wavelength we're working at. So we're going to send the red light. So we just calibrate that. Okay. Okay, so I have rinsed the cuvette with our control solution. So our absorbance for the control (2.21 2.1 seems to vary in the thousandth place. 2.21, we'll call it. I'm not putting a lot of faith in that last digit. All right, so this is our cooled solution. Let's test its absorbance. Pretty close, but you can see that it is a little bit higher. The absorbance is a little bit higher when the solution is cooled. So that means when you remove heat, it favors the product. All right, so in part C, we're going to be looking at the chromate equilibrium system. And the first thing to note is that the chromate is a very vibrant yellow, like a school bus yellow. And so our first reaction to tube 2 is going to be with sulfuric acid. So let's go ahead and add some sulfuric acid. We get a very neon orange color. So let's see what happens when we add sodium hydroxide, when we add a base. By adding the sodium hydroxide, we get a reversion back to our original color.
You're the cutest. Look at you. Like your cheeks rubbed. Yeah.